Bonjour 7.1 is about adding and subtracting polynomials. What's a polynomial, you may ask? Well, there's a lot of vocab you're going to need, so get your notes ready. We're going to talk about monomials, degrees, polynomials, binomials, trinomials, degrees of polynomials, leading coefficients, what it means to be a closed system or set, and standard form for polynomials. So it's a lot. So let's jump into what all of these words mean. First of all, a monomial is just a single term. So it could be a number, like 10 here is a monomial. It could be 3x, like this. It could have a coefficient and a couple of variables, even an exponent. So 1/2 ab squared is a monomial, even though it has a few parts to it. Negative 1.8 m to the fifth, that is a monomial. So all of those are examples of monomials. And then not a monomial would be like 5 plus x. That is a binomial, which we're going to get to on the next slide. A monomial cannot have a variable in the denominator. A monomial cannot have a variable in the exponent. And the variable must be a whole number exponent. So there we go. That is what makes something a monomial. So a monomial is a number, variable, or the product of a number and one or more variables with whole number exponents. All right, get that in your notes. Now, the degree of a monomial is the sum of the exponents of the variables of the monomial. Sounds very complex. The degree of a non-zero constant term is 0. The constant 0 does not have a degree. So, for example, if you have the monomial just 10 or any straight up number, the degree of that is 0. 3x to the first, there's an invisible 1 there, the degree is 1. 1/2 ab squared, there's an invisible 1 with the a for the exponent, and a 2 for the b. So this has a degree of 3. You add up the exponents. And negative 1.8 m to the fifth has a degree of 5 because the exponent is 5. Okay, a lot of vocab. Hopefully you added that to your notes. Maybe even made these lovely tables, which you will also find in your textbook if you need to find them later. Now, let's talk about polynomials. So a monomial is a single term. A polynomial is made up of more than one term. If you have two terms, like this one, which is 5x plus 2, that is called a binomial because there's, two terms. And if it has three terms, that is called a trinomial. Both of these, a monomial, a binomial, and a trinomial, are all forms of polynomials. Poly meaning many. So there we go. Also, you can have, 5, 6, 7, 8, 12 terms if you want. Those are all polynomials. Okay. And then the degree of a polynomial is the greatest degree of its terms. And then, so like if you have this one here, you got 2x to the third, that has a degree of 3. X squared has a degree of 2. 5x has a degree of 1. And the constant term has a degree of 0. The degree of this whole polynomial here is 3. It's the highest degree of any of the terms in the polynomial. Woo! That's a whole lot of vocab, which is why you're taking notes, because you don't want to have to remember all of this all the time. You want to be able to refer to it in your notes. Okay, and then a polynomial is in standard form when the exponents decrease from left to right. So you want to have the biggest exponents written first, going all the way down to the constant term at the end. And then when it's in standard form, the coefficient of the first term is called the leading coefficient. So here, if we put the biggest exponent term first, this 2x cubed, the 2 here, that's the leading coefficient because it's the coefficient that goes with the biggest exponent term. All right, you might want to add all of that. If you have a highlighter, that would be a great thing to highlight these important words and put that example there. It's a great example to have. And now I think I can actually start asking you questions now that we're a couple minutes in this video. And all that you've done is write down notes. Here we go. So rewrite 15x minus x cubed plus 3 in standard form. All right, so hopefully you put the negative x cubed first, because that is the biggest, highest degree. So there we go. So negative x cubed first, and then the 15x would be second, and then the constant term goes at the end. I was going to say something. I can't. Oh, yeah. So here, if you have minus x cubed, that means that your leading coefficient here would be -1. You put the minus with the x cubed. And then it's a positive 15x, so you put plus 15x. All right, so take a look at that. That's a great example. Might want to add that also to your notes. And then it already has the answers on here. For the leading coefficient, it's -1. And then the degree here is 3 because it's -x cubed. So third power, third degree. So here we go. So for this one, it's in standard form. It's only a monomial. There's only one term. You can't do anything else to it. But for A here, what is the degree for A? All right, so the degree for A, oh, is it going to show all the answers at once? I hope not. Oh, no, it doesn't. All right, so the standard form for that one is itself. The degree is 4 because it's to the 4th power. And then the leading coefficient's -3. It's the only coefficient here. What type of polynomial is it? I've just said it in the video, but there it is. It's a monomial. There's only one term. All right, for B here, rewrite that in standard form. Okay, so hopefully you've rearranged it. Put the 5x squared first, and then the x term second. This minus goes with the x, and then it's a positive 4, so it's +4 at the end. What is the degree of that polynomial? It is 2, because it's 5x squared. The exponent is 2. And what type of polynomial is this? It is a trinomial because there's 3 terms. Okay, and the last one, we have 8q plus q to the 5th. Put that in standard form. The q to the 5th goes first. What degree is this polynomial? It is a 5th degree polynomial because it's q to the 5th. And what type of polynomial is it? Yeah, it's a binomial because there's 2 terms. All right, now you're a master of this vocabulary. Fantastic. Let's jump into writing polynomials when you have to simplify. So you're also going to have to add and subtract polynomials, combining like terms. They're using a new term, a new vocabulary word called closed. What that means is, so if you're adding or subtracting polynomials, you end up getting a closed set because when you add like terms, you don't change the term. So if you're adding like a 5x squared and a 3x squared, you get 8x squared. You stick with the x squared. That doesn't change. So a closed system basically means that the type of thing you get for your answers are the same types of things you have in your set to begin with. All right, we'll talk about closed and open sets more in the future. So, what are we looking at here? So the polynomial is closer. Oh yeah, here we go. This is the main thing that you need here. The sum or difference of any 2 polynomials is also a polynomial. Makes sense? And to add polynomials, you add like terms. You can use vertical or horizontal format. So it's sometimes helpful to line up your like x squareds and your x's and your constants like that way, if you like adding that way. Or you can just, write them out horizontally. It doesn't matter. You just have to remember to put the terms together that are like terms. Let's jump into practicing some of this. So for this one, we're going to add these together. It might help to put them in standard form first, and that way it's easier to keep because all of your biggest degree terms will be first and all your constants will be at the end. You don't have to though, but it's generally easier to put them into standard form first. So see what you can get when you combine these 2 polynomials together for A, and then we'll go over it. All right, so you could line them up vertically. Notice this 2x cubed doesn't go with the 2x squared because they're not like terms. It goes with this 1x cubed up here. So that's why it's often good to rewrite them in standard form. And then you got -5x squared will go with this 2x squared. And then you don't have an x term in this second polynomial. So this x is on its own. You don't have a constant term in this first polynomial, so this -1's kind of on its own. Then you just draw a little line and add them together. And you get 3x cubed minus 3x squared plus x minus 1. So this is it's called a closed set or closed system because when you add these 2 polynomials, you get a polynomial. Okay, let's try. Oh, and there's the answer there. You might want to add this example to your notes. This is a great example. And now try B here. So add up B. Let's see what you get. All right, so you can add up the three. Oh, and they're showing you how you can, instead of lining up vertically, you can just line them up horizontally. So you can combine the 3x squared and the x squared. You can combine the x and the 4x. And you can combine the negative 6 with the negative 10. Why did they put a positive 10 here? Oh, because it's a positive 10 here. Hey, look, it's a typo. They made a typo right here. If you're copying this down, this one right here, that should be a plus sign. They made a mistake there. All right, so then you add up the like terms, and you should get, it should be positive 4 because you're adding a negative 6 and a positive 10. And there we go. So another great example, again, if you're copying this example down, this one right here, make it a plus sign. They messed up there. Okay, now let's jump into finding the difference. So the only trick with these, some of you are going to forget to distribute this minus sign. Every term in this polynomial is being subtracted. So it's like distributing this minus sign. So let's see how they did this first one, and then I'm going to have you do B. So my guess is they're going to line it up vertically. They are. And keep in mind that when you're subtracting each of these. So this is like 4n squared minus a negative 2n squared. That's like adding. So that, they're showing you right there. You can just switch all the signs. Okay, so if you're doing minus a negative, that's just plus. If you're doing minus a positive, that's a minus. And if you're doing minus 4, that's like plus 4. So when you're subtracting, this is a good way to go. And then you turn it into an addition problem like this. So there you go. That's a great example for A there. So now what I want you to do on your paper, try to do B. And you can line it up vertically, or you can try to do it horizontally, whatever you want to do. Okay, let's see how you did. So here you're subtracting 3x squared from 4x squared, so that gives you 1x squared. And they are, showing it grouping. It's negative 3x minus negative x is like negative 3x plus x, making negative 2x. And then 5 minus a negative 8 is like 5 plus 8. So when you subtract a negative, it's like adding. So you end up with that. Okay, so again, great examples to add to your notes. You'll have a lot of problems like this on big ideas. And then the last thing we're going to do is a story problem. And because this video is going on forever, I'm just going to kind of click through, and then you can add whatever you want to your notes here. A penny is thrown straight down from a height of 200 feet. At the same time, a paintbrush is dropped from a height of 100 feet. I don't know why people are dropping things out of buildings. This is not safe. Not safe. Polynomials represent the height in feet of the objects after t seconds. So that is the first one for the penny, and that's the second one for the paintbrush. And then it says, interpret the write a polynomial that represents the distance between the penny and the paintbrush. So is this going to be an addition or a subtraction problem if you're finding the difference between them? Okay, so it says you got to subtract. So anytime you're looking for the distance between or difference, you want to subtract. So you're going to take the penny equation and subtract the paintbrush equation. Remember, when you're subtracting, if you're subtracting a negative, it's like adding. So there we go. And you end up with this equation right here. And then it says interpret the coefficients of the polynomial. So some of the problems you're going to be doing are then going to ask you, what does this stuff mean? So in this case, this polynomial right here represents the distance between the two objects for t seconds. So when t equals 0, the distance between the object is 100 feet. So that tells you that at the beginning, when they're first dropped, they are 100 feet apart, which you can kind of see in the picture here. And then as the value of t increases by 1, this value decreases by 40. So they get 40 feet closer every second. Okay, there we go. So that is a lot of stuff, a lot of vocabulary. Hopefully you took some great notes. If you need some help while you're working through the problems and big ideas, let me know, and I will see you in class.